Hello, good evening. Hello, good evening, everyone. Can you hear me?
Yes, ma'am. Good evening, ma'am.
Good evening. So, should we wait for 5 more minutes if any other is joining?
Hello, good evening, ma'am. Ma'am, I have a doubt, ma'am.
Yes.
Ma'am, for end-term exam, we have to, ma'am, prepare for all the weeks, from week 1 to 12, or just after, ma'am,
Isn't it mentioned in the discourse? Like I think they have put there, right?
ma'am, as it was there, for quiz 1, we have to prepare from 1 to 4, and from for quiz 2, we have to prepare from 5 to 8, ma'am. But end-term, I don't know, ma'am. That's why I was asking you, ma'am.
No, I have like told to put in the discourse.
Ma'am, it's not there, ma'am. I have not seen, ma'am.
Okay, I will confirm. Hello. Yes. Hello. Who was there? Hello. Can you hear me?
Yes, ma'am.
Yes. The like majority part will be from week 9 to 12 only. The syllabus is from week 1 to week 12, but majority will be 9 to 12. Week 9 to week 12.
Okay, ma'am.
Okay. Today we are going to discuss about week 12 doubt session, right? Have you watched the slides for week 12 solve with us questions? Or if there is any doubt from week 12, please post here. Please ask me. We will discuss them. Hello. Do you guys completed week 12 lectures?
Yes, ma'am.
Okay. Any doubt from there? We are going to discuss that only.
Hello, ma'am.
Yes.
Ma'am, I have a doubt in activity 12.4, question number 6.
Yes. Just a minute. Hello. So yeah, it's 18. We will start now. So yes, what's your question? Question number 6, right?
Yes, ma'am.
Okay. Are you able to see my screen?
Yes, ma'am.
Okay. So yeah, in this question, what is there? Two continuous random variables x1 and x2 follows exponential distribution with parameter lambda1 and lambda2. Then which of the following could be the probability density curve for x1 and x2? Okay. For like to check whether it is a probability curve or not, what is the main focus? Like, how will you check that? Like, if it is given that there is some probability curve for the given distribution, then in which direction you will start? I'm just asking the approach.
Ma'am, above x-axis.
What above x-axis? What?
Ma'am, the first quadrant.
First quadrant. Okay. What bit? Like generally, see, whenever the PDF is there and they are asking, is it like a PDF curve or is it will it be the PDF for the given distribution? We have to just check whatever given is its integration or its area under the curve, is it equal to 1? Because we know that whenever uh, we sum up all the probabilities, it should be equal to 1, right? But it's a continuous distribution, so we will go for the integration. That means area under the curve. So we have to check that only, right? For exponential distribution, uh, what is there? It's like for what is the PDF there? If you remember it.
Lambda e to the power minus lambda x.
Yeah, right. And for x greater or equal to 0. So just go like that. So like, what's your doubt here? I'm not getting that only. Like I will tell you the answer definitely, no problem. Just let me know first. How did you approach it?
Ma'am, I I didn't get it.
Okay.
I got what you explained, but
Okay, fine. So just like take the integration lambda like e to the power minus lambda x is equal to 1. Okay. And the limit is here. We can see it, right? Integrate it with the formula. We don't know the lambda value, right? Do we have any idea for lambda?
no, ma'am.
Okay. Then how will you go with that? Whenever the x is greater or equal to 0, your f of x is lambda into e to the power minus lambda x, right?
Yes, ma'am.
Okay. So, Yeah, f of x is equal to lambda into e to the power minus lambda x whenever x is greater or equal to 0. Fine? 0 otherwise. Anyone else want to say about anything regarding this question? Yes, hello. Hello. Am I audible? Hello.
Yes, ma'am.
Oh, sorry, it was just disconnected. Extremely sorry.
Okay, ma'am.
Okay, just a minute. So yeah, in that kind of question, just remember that both are the exponential distribution, and we have given that lambda 1 is greater than lambda 2. What can you predict with this lambda? It seems there is some technical issue, so I'm just sorting it out. So that's why I'm discussing orally. Just give me a second. Yeah. So when lambda 1 is greater than lambda 2 in exponential distribution, how will you, like, what can you predict then about the distribution?
Ma'am, which question you
Yes.
ma'am, which question you discussed?
12.4, question number 6. Sorry.
Ma'am, your screen is not.
Yes, my screen is not I am not able to share. Just a minute, I am sorting the issue. Like once we know that there is two exponential distribution, and given that one lambda is greater than another one, then how like what will you think about that? Just give me a 1 minute, right? So yes, any like any guesses about that?
Yes.
See,
Yes, ma'am. Yes, ma'am.
yes,
Ma'am, if lambda 1 is greater than lambda 2, then function value of la- value of f of x1 is less than f of x2.
yeah, definitely. Because we know that in exponential distribution, what mail ID? Just a minute. In exponential distribution, we know that uh, like it is directly proportional to lambda, right? When we write PDF, it is nothing but the lambda into e to the power minus lambda x. That means we can say that x1 and x2 both, x1 is directly proportional to lambda 1 and x2 is directly proportional to lambda 2, right? And once we know that lambda 1 is greater than lambda 2, that means, yes, anything, f of x1 will be definitely what? Whose decay rate will be higher? X1 or x2? Yeah.
X2, ma'am.
Yeah. Yes. Who have asked the question? Uh,
Mummy.
yes. Are you getting my point? What I am saying? I will just share my screen. See what they have given that. Okay. Is it visible now?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Yeah. So can I write this as like see x1 and x2 both are exponential distribution. That means when they say exponential distribution, first thing comes in mind is what? PDF of the function, right? And
Yes, ma'am.
PDF is like that. If some function is like that, I can say that f of x is nothing but the and given nothing but this one, right? Uh, and given that lambda 1 is greater than lambda 2. So in this format, once you put lambda 1 greater than lambda 2, what do you observe? And once lambda 1 and lambda 2 for two distribution, they are different. That means this distribution are obviously not same, right? Is it so? Because what is the main factor between any two distribution when it comes to exponential distribution? See, we know that exponential distribution will give you PDF greater than 0 only, right? Whenever x is greater than 0. Yes?
Ma'am, your screen is not visible.
Okay. Is it now? Hello?
No, ma'am.
Okay.
Is not. Okay.
Yeah, now it's
How it's visible?
Okay. So lambda 1 is greater than lambda 2. That means the decay rate of x1 will be higher than decay rate of x2. If you write f of x1, like PDF for f of x1, how will you write it? It will be something like lambda 1 e to the power minus lambda 1 x, right? Whenever x is greater or equal to 0 and 0 otherwise. Fine. And f of x2 will be lambda 2 e to the power minus lambda 2 x whenever x is greater or equal to 0, 0 otherwise. Fine. So in both the PDF, what is the main difference? This lambdas, right? And they said this lambda 1 is greater than lambda 2. That means your x1 and lambda is nothing but the like parameter there, which generally and exponential graph, if you know e to the power minus x kind of graph, you know it's a decreasing function, right? And it's decreasing with the factor lambda in this case. Oh, sorry, this lambda x is in the power only, and do not confuse with that. Yeah, so this is decreasing function with some factor lambda. So once your lambda 1 is greater than lambda 2, that means decay rate or like whatever you say, it will be the rate of decrease for x1 will be greater than decay rate of x2, right? Are you getting why I am writing this?
Yes, ma'am. Yes,
Right.
ma'am.
Yeah, because this is the only, from this point only you will get. Once you say someone for f of x1 decay rate is more than f of x2, that means the slope like there will be a steep graph for for f of x1 as compared to f of x2, right? And on an average, the PDF will be less. See, once let me check the question. Yeah, here. See, for the first graph, if you see, your blue line is x1 and red line is PDF for x2. So, is it correct according to whatever we have discussed? According to that, the steepness of PDF for x1 will be more than that of x2, right? From graph 1, what are you getting? Who is more steep? Red color one or blue color one? Red one. But red one is for x2. So definitely this is not the graph for the given curve, right? Are you getting why I am discarding the option 1?
Ma'am.
Yeah. Then let's go to second option. What about here? Here, this red one is for x1. And we know that once lambda 1 is greater than lambda 2, that means the average decay will decay of x1 will be greater than x2 because of lambda 1 is greater than lambda 2, right? That means the decay will be faster for x1 as compared to x2. So in this second one, which graph you can see that this x1 is red here. So this will be the this should be our answer. Let's move to next option. This one is incomplete as they have nothing graphed for x1. Okay. So for the given conditions, when x1 and x2 are following some exponential distribution where lambda 1 is greater than lambda 2, then your graph probability density curve should be like that. It's just steepness you have to check which one has more steepness. Did you get the point? Does it solve your doubt, or is there anything else also? Hello, are you there who have asked the question?
Yes, ma'am. Yes, ma'am.
You got the solution or what?
Yes, ma'am.
Okay. Then what is the next doubt?
Question number 3, ma'am. Same
Uh,
activity.
In
12.4 activity.
12.4, question number 3. This one.
Yeah.
Waiting time in a hospital is said to follow the exponential distribution with the expected waiting time of 10 minutes. What is the probability that person visiting a hospital has to wait for more than 15 minutes? Yeah. So what is lambda here? And what do you have to calculate? It's just a calculation.
Yeah, I solved it, ma'am, but the answer is not matching the one.
Okay. What have you put for the lambda?
10.
Lambda is
1 by
equals to
Is
0.1.
it given that, yeah, expected waiting time is given 10. What is expected given time? Is lambda for expected time? No, right? Expected time is nothing but the
1
expectation
upon
of, yeah. So it's a 12.4, question number 3. Yeah. Expected time is given 10. How will you how do you find the expectation for exponential distribution function? It's
1
nothing
by
but the
lambda.
1 by lambda. It is given that 10. So your lambda value is 10. Sorry, 1 by 10, that is 0.1. Fine. And it has asked what is the probability that you have to wait more than how much? 15 minutes.
When I
Probability
did 1 minus less than 15 minutes.
x greater or equal to 15. Yeah. Yeah, you can have x greater than only. So you can use directly PDF formula for that. 1 minus probability, sorry, CDF formula. X less or equal to 15.
Yeah.
So what's then?
Yes, ma'am.
1 minus e to the power minus lambda into 15, right?
Yes, ma'am. Minus lambda gives the value 1 upon 10.
Yeah. So it's a minus 0.1 into 15. So yeah, that's it.
Ma'am, in exam, how to calculate
This
E?
value will be given in the question only. So you do not
No,
have
ma'am.
to.
In the
E on
calculator,
Or the
calculator.
C will be there, yeah. So it's e to the power minus 1.5. Okay. Yeah. Next.
okay. 12.2 activity, 12.2, question number 9.
Sorry, which one? 12 point. Hello.
12.2, question number 9.
12.2. We have discussed 12.2, right? Were you there?
No, ma'am. I think I was facing the same problem. I was not able to get the answer.
Yes.
Can you explain just a little bit?
Yeah, we have discussed that, but okay. Yeah. Suppose that random variable x is uniformly distributed between 0 to 10. Then find the probability for x plus 10 by x greater or equal to 7. Here nothing is there. See, it's x is 12.2, question number 9. Yeah. X is following uniform distribution between 0 to 10. Fine. and you have to calculate probability x plus 10 by x greater or equal to 7. How will you go with that? Can you solve this one? X plus 10 by x greater or equal to 7?
Okay, we have to solve it first.
By
Okay.
integration.
Yeah, first solve it. Okay, I'm giving you the idea here. This will be like your when you solve it, you will get your x will lie between 2 to 5.
Five.
Okay, and then okay, but we have to calculate probability of x plus 10 by x greater or equal to 7, right? And this inequality lead us to here. That means this is greater or equal to 7. We need 1 minus probability of x lying between x less or equal to 5, right? And you have to just, we know that how to calculate this part, right?
Yes.
So just calculate like that, as we have discussed this question in last
Yes,
lecture.
ma'am.
That's
Last
why I'm
class.
not going in the detail. You can have that lecture in YouTube also.
Can you just go through one more question, just little bit uh, explanation.
Yeah, which one?
Question number third. Question number third.
From this 12.2.
Yeah.
Okay, question number 3. Yeah, the total duration for the test cricket match between any two cricket team is uniformly distributed between 30 and 40 hours. Fine. So this is 30 to 40. What is the 65th percentile for the duration of the test cricket match between any two cricket team in hours? Fine. We have to just calculate that part only. This also we have discussed. See, x is uniformly distributed between 30 to 40, and it's asking for the x greater or equal to k, which is equal to 0.65, right? Because 65th percentile they have asked. Sorry, x less or equal to it was. So with less or equal to, you know that what is this? This is nothing but your f of k, right? What is f of k?
Yeah.
It's your CDF. And for uniform distribution function, you know how to write you know how to find the CDF, right? We have solved it. It is nothing but the x minus a divided by b minus a. What is x here? Your k. What is a? This one is your a, this one is your b. See, if
I
x
got
is,
the point.
yeah,
I was just little bit confused with the percentile part. Not
yeah, you have to just solve this. That's it. Okay. Next, then you can solve the k value, right? It is like 10, 6.5, 36.5. Fine.
yeah.
Okay. Any other question? Do you get the time to visit the solve with us question, or should we
Ma'am,
start
can
that?
you repeat the previous question?
This k value?
What? Yes, ma'am. Okay.
Okay. See, when x follows uniform distribution between A to B, then its CDF and PDF we have calculated. So I'm giving you, in this question we need CDF, so I'm just telling about CDF. What was the CDF for x? Anyone? It was nothing but the f of x is equal to 0 when x was less than a. It was x minus a upon b minus a whenever x is lying between a to b. Fine. And it was 1 otherwise. Fine. Otherwise, or you can say x greater than b. So yeah, this f of x less or equal to k is nothing but the format for CDF. and f of k is there, so you can put directly formula because we want this one only. So yeah, by solving this you will get this value k. Here it was the main thing that probability x less or equal to k is representing CDF. Once you know CDF, the question is asking about CDF, you know the formula, you will put and get the answer. Okay. Next. Okay. Have you guys got the time for this week 12 slides?
Yes, ma'am. Carry on, ma'am.
Okay. Is there any doubt from any of these questions? Hello?
Hello, ma'am.
Yes.
Ma'am, can you discuss 7th question?
Sorry, which one?
7th.
7th question. Okay.
12.2.
12.2.
Yes, ma'am. Ma'am, I got the wrong answer.
Suppose the random variable x is uniformly distributed between 8 and 24. Find the probability for x which is lying between 10 and 20. So yes, what is problem here? Like, what is the doubt here? Have
Ma'am,
you
I solved it like 10 by 16. Then I got wrong.
10 by 16? Yes.
Then I got wrong.
It was giving wrong answer.
Yes, ma'am.
Maybe calculation mistake. It is nothing but the probability. See, yeah, x is distributed uniformly between 8 and 24, and you have to calculate the probability for x lying between 10 and 20. How will you go with that? How will you calculate it? It is nothing but the probability x less or equal to 20 minus probability x less or equal to 10, and both lies in the range 8 to 24. So you know that how to calculate. This is nothing but the CDF for 20 and this is CDF for 10, right? And what is CDF here? As it is a uniform distribution, your CDF is x minus a. What is your a? It's 8, and divided by b minus a, 24 minus 8. Same thing for 10. Right? So it will be 12 by 16 minus 2 by 16. So it's a 10 by 16. Yeah. Did you get the solution, or like did you find where it was your mistake? Hello? Yeah.
Hello,
Yeah, yes.
ma'am. It's right way, na?
Yeah.
Then
Okay. Any next question?
Ma'am, in this question, first we also find the PDF is equal to 1 upon B minus A.
Okay. But is it asked there, like in question, do we need a PDF?
No, ma'am.
Yeah, we can find the PDF. Yeah, PDF is 1 upon B minus A. That is 16 only, right? 24 minus 8, 1 by 16.
Yes, ma'am.
Yes, anything else? Like it's a doubt session, right?
Ma'am, I have a small question.
Yes.
In mathematics, we are given the PDFs for practice assignments also. So
Okay.
can we get that in statistics also? It will be of immense help, ma'am.
Okay. In portal, there are some practice question, right? I think that's it.
Yeah, but what happens is in mathematics, we have solutions for both graded as well as practice session questions.
Okay.
So during preparation, it will help a lot to check whether we have missed something. Or
Okay.
for activity questions, you're helping a lot.
Okay. I will confirm and let you know.
Yeah, I put a message on
Discourse.
not I don't have access to discourse, but I put it in groups
Okay, okay, fine. Like,
because exams are final exam is coming now, ma'am.
yes, yes, yes.
If
Like,
it can
do
be
you
done.
need the solution? Then we will post there. Like maximum of the part we have discussed in the lectures, like in the open session and doubt session.
Yeah, we have,
But
but
still, yeah,
just to revise, or it will be a very quick refresher.
yes, yes. If you want, we'll provide. No problem.
Thanks, ma'am.
Yeah.
Ma'am,
Yes.
ma'am, when we are describing a normal distribution, like the notation, how can we show that be sure that it is variance or standard deviation?
Variance you denote by sigma square, right?
No, like if just a number is mentioned, like,
Okay, like that. If it is given that n is following some 4,9, like that
yes,
you are asking?
yes, ma'am.
Yeah, it's always a sigma square.
Okay.
Yeah.
Okay, ma'am. Thank you.
Yeah. Okay, any other doubts?
There is one question, I'm finding it. Just give me a second, please. Sorry.
Yes, please.
Can I just I actually I can post the screenshot. Let me just give me a second.
Can you read the question? I'm not there in the discourse or group.
Ma'am, I posted it in the chat actually.
Okay, fine.
I'm not sure if you discussed this question.
This question we recently discussed.
Okay.
Just like,
I will look it in the YouTube in the link.
yeah, this question we have discussed like for 2 or 3 times.
Okay, ma'am.
Okay, no problem. See here only. Yeah, it is.
Okay. We just solved the equation and
Yes.
okay, ma'am.
We have to just solve the equation and just take care that whatever we are solving is solving for like
X.
term greater or equal to 7.
Okay, ma'am.
So we need to convert it into CDF because we do not like, we can't solve like that, right? So 1 minus is important. Otherwise, your calculation all stuff is equal. But this will create a big problem.
Can't we just say like 1
Yeah.
minus e greater than 7? Like some, because can't we just like take the x plus 10 by x like one term?
Yes. You there is like that kind of concept is also there, but you will learn that thing in stat 2. There are many things, so we have to adjust according to that. We have to change the range also. But see here, x is following uniform distribution from 0 to 10. So once you put x plus 10 by x as something, you have to take care about each and every value between 0 and 10. Okay, and here x is in denominator. So there is some other kind of calculation that you will learn in stat 2. So till now we have to go like that.
Okay, ma'am.
Ma'am,
Yes,
12.3, question number 1.
12.3.
Ma'am, back option number second is incorrect.
Question number 1 or 2 or both?
One.
Okay,
Only
yeah.
one. No, I talk about option second.
Okay. See, which of the following is probability density function? For any distribution function, when it comes to PDF, we know one rule, right? If it is a discrete distribution, then we just go for the summation. But whenever it's a continuous kind of distribution, we go for the area under the curve. And it should be equal to 1. So we have to calculate that thing only. That's it. So like in first option, let's say this is 0.3, right? But it seems less than that. From, yeah, we have to check that only. Let's say it's 0 to 1 tab. Yeah. For first option, if 12.3 question number 1. Yeah. So our integral negative infinity to infinity f of x dx should be equal to 1, right? We know that for rest of the part, your f of x is 0, like till 0, from negative infinity to 0, it's a 0. From 0 to 1, what is your f of x? 0. Your f of x is nothing but the 0 only, right? We'll go like that. From 0 to 1, what is your f of x? It's 0.3. Fine. Hello. One to 1.5. What is your f of x? Here it is 1. Plus. Then from 1.5 to 2, what is your f of x? It is something about 0.5, right?
0.5.
1.5 to 2, it is 0.5 dx. The rest will be again 0. From 2 to infinity, your PDF is again 0. Fine. So we have to just check whether this integration is equal to 1 or not. Okay. So just
Okay.
calculate it what it is. Is it 1? So it will be 0 plus 0.3 into 1 plus 1 into 1.5 minus 1 plus here it is 0.5 into again 2 minus 1.5. So yeah, clearly it's more than 1, right? It is 0.3 plus it is 0.5 plus it is 0.5 into 0.5. 0.25. Oh, sorry, it's less than 1. Yeah. See, 0.3, 0.5, 0.25. It's what it is. So it's not equal to 1. Yeah, so it's not equal to 1. We need just, is it equal to 1 or not? That's it. That is our concern. That's it. We know that it's not 1, so it's not your PDF. So just go for the second option and check whether it is giving you 1. If it is, then that is your PDF. See, for the second option, sorry, it will be 0 to 1, it's 0.5.
Ma'am, but option first is correct.
No?
Yes, ma'am.
Like the same option is there, like just check.
1 minute. Yes, ma'am. Yeah.
Okay. So it might be like 2.5, right? We have taken it as a 0.3. It's obviously less than 0.3. We can see here.
0.25, I think.
Yeah, maybe.
Yes, ma'am. Yes, ma'am.
So once it is a 0.25, it's correct. Right? You got my point. Yeah. Like what we have to check. We have to check whether the integration is equal to 1 or not. If it is discrete, then go for summation. If it is continuous, go for the area under the curve.
Yes, ma'am.
Okay. Yeah.
Thank you.
Ma'am?
Yes.
Ma'am, can I ask question from graded assignment 12? Is it like
I
being...
think it's a deadline today, right?
Yes, ma'am.
So you can't. It's a graded only, no?
Like I have answered the question, but I want to ask a conceptual question basically.
But it's you can post in the discourse. We can discuss in the next session.
Sure, ma'am.
Yeah. As it as its deadline is today, that's why I can't.
Yeah, it's okay. I will post it
Okay.
in next
Yeah.
one.
Sure. Okay. Is there any other question from week 12 session, week 12 part?
No, ma'am.
Okay. Then any conceptual question you want, then we can discuss that. Otherwise, we can end here. As we have discussed the assignment in last session, so the doubts are also taken. So if there is any doubt, then please ask me or post in the discourse if you are not getting what to ask now.
Ma'am, actually there is one question. Just give me a second.
Yeah.
I was
If question is there, then please inform me so that I can meet.
yeah, it's week 9, AQ 9.1,
Yeah.
and it's just a second. It's question number 8.
Okay.
So should I post the question? Let me post the question actually.
Week 9, it's which one?
Question AQ 9.1.
9.1. Question number
It's question number 8.
8. Okay.
So basically, ma'am, like I got the answer, like the proper way to do it. But
Yeah.
if I'm doing it in a different way, let's say I'm like picking slots, like for the first slot, this is the probability, and I multiply it out. I'm not getting the answer that way. It's like, do I
Okay.
make sense?
Okay, let me check. What is the question? This one, right? A small village has 120 female
Yes.
voter, 90 male voters. A sample of 10 voter is chosen. Let a random variable x be defined as the number of male voters in the chosen sample. What is the probability for x is equal to 5? Okay, x is the number of male voters. Okay.
Like this is hypergeometric, right? So like I get it. Like if I use the formula, I get the answer.
Yeah.
But like because till 9.1, hypergeometric was not discussed.
Okay.
So like when I was doing that time, I was doing it I was multiplying the probabilities.
Okay.
For the first slot, this is the probability, let's say, from like 90 divided by 210 into, so on.
Yeah.
We can do this question by combination also. No, I think
Yeah.
second option is true.
Yes, ma'am.
Am I right?
That way I know, like that I got it. But if we want to do it that way, is it possible? Like if I do probabilities, like multiply.
Will you please explain once more? I'm not getting like how you were trying it.
So basically, like we are picking 10 slots, right?
Yes.
So for
Yes.
the first
Sample of 10 peoples, and we need that number of male voters are 5.
5, yes. So
Yeah.
let's say we are picking the probability of picking a male voter for the first slot is 90 by 210.
90 by 210. What?
90 male over
Wait, just a minute.
210 total voters.
Yeah, 90 by
210.
210. Acha, total.
Yeah. And then for the
What
second,
is this by the first? Yeah, then okay.
probability of picking male for the first slot.
Yeah.
And then
Is there any sequence we need? Okay, you go ahead. 90 by 10, then 89 by
209.
209. Yeah.
Yes.
Yeah. And then
So
we
I
will multiply 88 like one less like that, right?
Yes, ma'am.
88 by 208 and
That,
multiplied by till 5, like, sorry, 87, 86.
yes, ma'am. Then 120 for females.
Okay, then say the same thing for females.
Yes, ma'am.
Okay. See, what's the problem here? This will not give you the correct answer. Definitely. Now your question is why, right?
Yes, ma'am.
Yeah. See,
Like
whenever you do,
get it, like I'm not getting the combination part. No, sorry, the permutation part probably somewhere.
Permutation, no. This is not combination.
This is not combination. This is conditioning part.
Yes,
You are applying conditional probability here. This is what the probability that first voter is male. This is what probability that second voter is male, given that first voter was also a male.
Yes, ma'am.
There is no need to put this kind of conditioning in the given question. We just need 5 males. If out of the 10, what is the probability that 5 are males? So just take combination. We do not need order when there is no need of ordering or conditioning. It's not like that first voter is male or second voter is male. The question is not like that, right? It is like out of 10, what is the probability that 5 are males, right?
That, ma'am, combination, like that way I get it. Like I got the answer.
Yeah.
But I'm just like for, just.
Yes, I got it. This kind of question we have when we were discussing week 8 and 9. At that time in the solve the session, this kind of question came. And we discussed like that, okay, whenever there is conditioning, then this kind of thing works there. That, okay, first male is chosen, now let's go for the second one. This is conditioning. We do not need conditioning here. That's why this method will not work.
Like even if we try different permutations or something, no, nothing?
No. Permutation is whenever ordering is there, permutation will play a role. Permutation is important for ordering the things or choosing the things in a particular order. Then we will go for the permutation. But here it is not like that, right?
Okay.
You're getting what's like choosing 5 people and choosing 5 people in a sequence. This is 2 different things, right?
Yes,
For
ma'am.
example, in a school where there are classes from class 1 to class 10. Okay. So it's a co-ed school, so there are boys and girls also. Now, let's say in first scenario, I'm asking you to pick any 5 boys. So you will pick any 5 boys. You do not have any restriction from which standard he belongs, right?
And basically, like the confusion is that's why I want to try the different permutations to capture that combination.
Yeah.
I want to add all those ways so that that choosing part is done. I don't
Yeah,
know.
yeah, yeah. But you can't do here. Did you get the difference? Why you can't do this thing? So that you do not do the same thing in exam. That's right to permute and like to find the different ways. But yeah,
But just conceptually, why is it not like working like this thing?
because it is conditioning. You are putting the condition on the when you are choosing this second male person, na?
Yes, ma'am.
At that time you are putting condition.
No,
Sorry.
that's like I get it. It's condition. I get the symbols and everything. But
Yeah.
like even then, why is it not working?
Because here you are putting conditioning. We do not require any conditioning. We do not require any order, any particular order. That's why this format is not working. You just need combination.
Like when I got the answer, like just the answer was so weird that I got it. Like it was wrong. Actually,
Yeah.
it doesn't.
Okay. Is your doubt clear or not?
Like I don't know. Conceptually, it seems it should be working, right? Like we are multiplying the probabilities, and like,
Okay.
I will still do it
Y-
through
You
hypergeometric now, but still.
see what is this 90 by 10? 90 by 210. What is this?
Uh,
If we just consider this part only, what is this?
Probability of male.
Probability of
Of,
choosing one male out of total people, right?
yes, ma'am.
What is this 89 by 209? Just forget about this thing, okay? Just forget about this thing. Sorry, 209. What is this?
Um, like picking male for the second if we have picked male for the first.
Yeah, but was it necessary?
Um,
Like it may be possible that first person is female, first voter was female. It is an like you have to. It's like that. In a let give me one example. Let's
exactly.
give me one example. Huh?
That's what I'm saying. Like the way you framed it, like let's say the first was female, right?
Yeah,
So is there a way to add all those probabilities? So this is one way
yeah,
plus something. That's what I'm asking with pretty much.
yeah. In permutation, let's see. Okay, let me try. Let's say there are three words A, B, C, D. Okay, these are four letters.
Yes,
Okay,
ma'am. Yes, ma'am.
and someone is asking you to form four-letter words using this four. How will you go with that?
4 into 3 into 2 into 1.
4 into 3 into 2 into 1. What you used?
Uh, ju-
Permutation,
yes, ma'am.
right? In permutation, uh, like for the first position, you always have four choices. Like you are putting first A, like A, B, C, D and B, C, A, D is different there.
Yes,
Okay.
ma'am.
But now I'm asking you, okay, give me like combination of four letters from here. Then
Combination of 4. Then it will be just one, like it will be all 4
why?
because we have just like 4
Okay.
words.
Because in this case, A, B, C, D and C, D, A, B are
Are,
not different, are equal. Okay.
yes, ma'am.
If out of four, if four is confusing you, then just reduce it to two. If I am asking you to make the two-letter words using these four, make the two-letter words. What will be your solution? What will be your reply?
4 into 3.
4 into 3. You used what?
Permutations choose.
Okay.
Yeah.
Yeah. Here A, B and BA both are considered. A, B and BA both are both are counted. This is first, this is second, like that, right?
Yes,
A,
ma'am.
B, BA, C, D, DA, and all these things. But same question I ask you, I'm asking you, give me any two letters from here. Then, or combination of any two letters, then
That
You
will be
will say
yeah.
4C2, right?
Yes, ma'am.
Why? You used combination this time. You used permutation now. Why you are doing like that? If there are 90 males, okay, and how many? 120 females. I'm asking you, okay, out of this 210 people, I have taken some sample size of 10, let's say 90 males, 120 females, okay. Now I'm taking, okay, 10, I have chosen randomly 10 people. I'm asking you, give me the probability that out of this 5, out of this 10, 5 are male. How will you go for that?
Well,
Let's say this 90 males are M1, M2 till M90. Fine?
yes, ma'am.
And yeah, and this F, like 20 females is F1, F2 till F20, F120. Then give me the probability that if I choose 10 people, then out of 10, 5 are males. How will you go?
Well, now I know the formula hypergeometric. Sorry.
Okay, no, leave the hypergeometric. Just come back to combinatorics and probability only, permutation only.
Well, I
What
will
will you
like divide in denominator. It will be total number of ways.
Yeah,
We take 10 people out of 210.
210.
210 choose 10, and on the top it will be number of ways we can select 5 males from 90 into, like it will be
That
the
is nothing but 90C5, right? Combination of 5 males, because this doesn't matter M1, M2, M5 or M80 to M85, right?
yes, ma'am.
Because there is no need of such kind of things, right? Okay. And for this 120C5, right? Why
Yes, ma'am.
didn't you use that one that you were
Like,
doing first? Like, why not this?
ma'am, sometimes, ma'am, ma'am, in quiz 2, that question that four people, 4 friends, 5 friends, I don't know if you know.
Yeah.
So I did it by hand.
Hmm.
Like I wrote every combination.
Okay.
Like I didn't know how to do it. So that's why I'm asking. Sometimes we have to know in
I
different, you know.
It's just check whether in the question the ordering matters or not. If if you have confusion like that, then if 90 males are given, then just take them as M1, M2, M90. Does it matter like M1 is chosen or M90 is there? Like in out of the 10 people sample,
Ma'am,
M1 is there or M90 is there? If it matters, then go with the permutation and then go with the things you have did here. 90 by 210 and all these things. Otherwise, you can go like that, a combination.
that, that thing I get it. I'm just asking like conceptually, like I'm not doing the actual math. Is it possible if we, do that plus 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 thing?
Plus,
I
plus, plus.
think I
Yes.
think that time they are talking about post like things like
Sorry.
posts are available. Then we can do this question like that way.
Harshit, right? Harshit, your voice is not clear.
I'm talking if they are talking about post like thing like posts are available. Then
Hmm.
we can do this
Can you
like
write on the
that way.
chat? I'm not here. You are not audible at all.
Okay.
Ma'am, like
Yeah, what you were asking, like combination, you can check the combination. Yeah, like see, 90C5 gives you the all possible combination of 5 males out of this M1 to M90. If you have a time, you can go like that. Okay, 1 to 5, then 2 to 6. Like that you are asking, right?
yeah, like different
If you do
like
not miss anything, then it's good. Like,
yeah, like I'm just asking like conceptually, is it like
yeah, it is like that only.
yeah,
If See 90 is very big number. So for combination, we can have this A, B, C, D. 4 letters we are choosing. Okay. If you can you give me the 2-letter combination from this 4-letter out of this 4? I am asking you 2-letter combination. Then you can go manually, right?
Yes, ma'am.
AB will be there, CD is there, then AC will be there, AD will be there. Then what? Anything left? BC is there, BD is there, CD. Anything else?
No, that's all.
Okay, then just calculate this 4C2. We know this formula also, right? These both should match. If they are not matching, that means we are missing something, right?
Yes, ma'am.
So it's 4 factorial divided by 2 factorial, 2 factorial. So it's a 3 to the 6. Why it is, sorry. Yeah. Yeah, it is 3 to the 6 only, right?
C2 is 2 times actually, you mentioned.
Yeah. What is NCR, by the way?
And
N factorial upon R factorial, N minus R factorial.
And choose R.
Yeah, and choose R. So here I think something is repeated. Yeah, CD is repeated. See, this is
yeah,
6 only.
that's what I said, ma'am. CD is.
Okay, I thought you are asking about this. Why 2 times 2 is here?
No, CD was repeated.
Yeah, CD was repeated. So yeah. So you got what, like when you go manually, this kind of mistake will happen. But this is how this formula came. This was the origin. Then then scientists, mathematician, they have found, okay, we can do the things like using this also. Then why to go with that, right?
I have a related I will ask it next time properly. I will frame the question properly.
Yeah, that will be good if you have question.
No, not this one. I'm just asking. Sometimes we are I don't have the perfect question right now, but we are multiplying probabilities, and sometimes we have to take care of the order, and sometimes we don't. Sometimes we
Yes.
just multiply the probabilities, and sometimes we like uh
Ma'am, I write in chat.
add the probabilities.
Okay. Yeah. Sure, you can have that thing. Then I will suggest you one thing. Just read conditional probability, permutation combination, right? And
Yes.
just go through conditional probability once again. So you will find the difference when we multiply and when we add or add to, okay, when there is only or part is there. So you just go by that, and if there is still any question, you can post in the discourse and also ask in the TA session, also in doubt session or any other session that we have in next
Yes.
time.
Yes.
Ma'am, I write in chat.
Yeah.
Oops.
Post like things. What is post like things? Yeah, post like. Yeah. Yes, you're correct. That's what we have discussed, right? Okay. Any other doubts?
Ma'am, I have a doubt.
Yes.
Ma'am, in week 12, practice assignment.
Practice assignment.
Yes, ma'am.
Okay.
Ma'am, in question number 6,
Question number 6.
yes, ma'am.
Yeah, amount of time student takes to solve the question is uniformly distributed with an average time of 12 and variance is 1 by 3. Find the value for probability of this one. Okay.
Yes, ma'am. Ma'am, I calculated it and I got the value of A and B, after calculating expectation and variance.
Yeah.
But ma'am, when I was solving, ma'am, can you open the solution of this, ma'am, please?
Solution of this. Okay, we can solve this question. No?
Yes, ma'am. Ma'am, I solved it. I calculated A and B value. But after that, I was solving it like f of 12.5 minus f of 10.
Just a minute. Yeah, it's x is uniformly distributed about something, and we have given that, let's say, a comma b only, right? And expectation of x is given what it is. It's what?
12.
Yeah. Expectation is 12, and we know that it is nothing but the a plus b by 2, right? It is
Yes,
equal to
ma'am.
12. And variance of x is given as
1 by 3.
1 by 3. What is variance of x for uniform distribution?
B minus
B
A whole
minus A
square.
whole square upon 12.
12 is equal to 1 by 3. Okay. Then calculate the probability for x lying between 10 to 12.5. Okay. Probability of... Okay, first we can have these values. Yeah. What was your A and B?
Ma'am, just a second.
And this will be
A was 11. Yes, ma'am. And B was 13.
11 and 13.
Yes, ma'am. A was 11 and B was 13.
Are you sure?
Yes, ma'am. Yes, ma'am.
A is 11 and B is 13.
Yes, ma'am.
Okay. Then
Ma'am, after that, I was calculating as it's given to find the probability from 10 to 12.5.
probability 10 to 12.5. Yeah.
So I
Yeah.
calculated it as 12.5 f of 12.5 minus f of 10.
Sorry, 12.5. Then you calculated it as a... First you
F
take
of,
just 10. Your range is 11 to 13.
yes, ma'am.
Okay. You went by like that, right? Probability, sorry.
F of 12.5. Yes, ma'am.
Yeah. Probability x less or equal to 12.5, and you subtracted from probability x less or equal to 10, right?
Yes, ma'am.
Then
F of 12.5 minus f of
Yeah.
10.
it is nothing but 12.5 minus a divided by b minus a, which is 2. Minus here.
Ma'am, I did it 12.5 minus 11 upon 13 minus 11 because B is 13 now.
Yeah, 13 minus what? 13. B minus a is 13, right?
13 minus 11 too. Sorry,
X
yes, ma'am.
minus a upon b minus a.
Yes, ma'am.
So
Got
yeah.
it.
And
And
this
then
will be
10 minus 11.
y. When probability x less or equal to 10, you can directly have 0. Why? Anyone can explain why this will be 0 directly? What is cumulative distribution function? Cumulative distribution function gives you the probability all the values that x can take before 10. Okay?
This will just because the range.
Because our range is 11 to 13. Yeah, your like logic was correct. When they have given, see, your A is 11 and B is 12. That means your x is uniformly distributed between this 11 to 13 only. Outside this 11 and 13, your probability is 0. Right? We have discussed these things when we started with the uniform probability, uniform distribution, that if this is A, this is B, then what is this? This is your PDF, f of x. And for rest of the part, your f of x, your PDF will be 0. Even though we
Yes,
know
ma'am.
what is the PDF also, it is 1 upon b minus a in case of uniform distribution.
Uniform distribution.
So when they are asking x less or equal to 10, 10 is outside outside your range, you can directly have it 0.
Okay, ma'am.
You got?
Yes, ma'am. Yes, ma'am. I got it, ma'am.
Okay.
And ma'am, I have more doubts, ma'am. And practice assignment one question, first question.
Practice assignment 1, 12.1. Oh, sorry.
On same practice
Yeah,
assignment.
practice assignment. Sorry. The amount of time in minutes that a person must wait for a train is in. Oh, sorry. Here. Here you have to find the value of k. Enter the answer correctly. Yeah. So, yes. How will you approach it?
Ma'am, it's non-uniform distribution. So I have to calculate the like fx by area under the graph.
Yes.
So I did it like half base into height
Half.
is equal
Okay.
to
Half
1
base into height. Okay.
is equal to 1. Then I got as height to be 1/2.
Okay. Height. How did you calculate it? Height.
From half into 4 into h is equal to 1. So it will be h is equal to 1/2.5.
But you can directly have integration is equal to 1, right? This is continuous distribution. And the function is given. And it is from 0 to 2 and 2 to 4. Just go with that function only.
How?
See. Whenever the x is continuous distribution, even though it's a non-uniform, but it will follow one thing, definitely. That is integral negative infinity to infinity. Whatever its PDF will be, this area under this PDF
Will be
should
1.
always be equal to 1.
Yes,
Did
ma'am.
they have provided f of x value?
No.
No. Why? What is this? F of x is equal to kx 0 to 2.
Oh, okay, sorry. Yes,
Yeah,
ma'am.
you have to just integrate like that only. 0 to 2
Uh,
integrate k of x, 2 to 4 this one. You will solve it. Should I?
Ma'am, but I was approaching it as height. I calculated height and I got 1/2. But after that, I like what should I do? I don't know. That's why.
But how will you go with the height? That's the problem, no? See, in this graph, like even though we can have that, okay, this will go to this point like 2 only, but this is not proper graph, right? So we can't, like we cannot like go directly like that. That way is also correct. You have to use Pythagoras and you will find that value of uh, your height. How did you calculated height, by the way?
Ma'am, it's I calculated it as like half base into height.
Yes.
Eight,
What is your base value?
4.
Yes. Okay. And
Ma'am,
height?
and height will be h only.
Okay.
Ma'am used this like in one
Yes,
of the
yes, yes.
examples.
Yes.
So
Ma'am,
I calculated it as height is equal to 1/2. It like
ma'am, base should be 2.
That's what first I am listening to her, like what she's saying. Then only, okay.
ma'am, but
Then
yeah, ma'am, but it doesn't make difference, na. If I take 2 or that height will be same only, na. If I take the area of the triangle of the whole triangle or only up to 2 or only up to 4, but height will be same, na.
yes, yes,
Yes, ma'am. He's right.
yes. You are right on. If you have the triangle, like someone has like talked something in between, na. If you take base as a half, then your integration will not go up to 1, right? Then you are considering the half of the triangle only. Okay, you are not getting value from that. Isn't it like same? Half into base into height, you are saying, is equal to 1, right? Area
Yes.
under the triangle, that's it, right? Yeah. So 1/2 into 4 into h. So it's not getting the correct one.
After that, what should I do? I don't know after that what.
Yes, yes, that's one. You are calculating h. What is you can have h is equal to what? This will be 1/2, right? So find h, na? You can find h. You know Pythagoras, right? Pythagoras
Yes,
theorem.
ma'am. Yes, ma'am. Yes, ma'am. Like
Go
hypotenuse
like
is
that. Yeah. Yeah.
okay. So, ma'am, then
So
x
your h square plus let's say,
h square is equal to base square plus
yeah,
perpendicular.
base square. What is your base then? 2 square, right? is
Yes,
equal
ma'am.
to which one is
No, ma'am.
simplest? Kx.
Ma'am, it will be yes, ma'am. Yes, ma'am. Yes, ma'am. Sorry.
When you apply the Pythagoras, then you do not have whole triangle, na? You want what
Yes,
is
ma'am. Ma'am,
right angle triangle.
yes, ma'am.
This was your triangle.
Yes, ma'am, I got it, ma'am. I thought that h is equal to hypotenuse.
Array, how?
Yes, ma'am, I got it. I like h same, na, so that's why.
Yeah. So I will take it as a k square x square, right?
Yes, ma'am.
Sorry, h square, h you know, 1 by 4, right? H square is 1 by 4, na?
1/4.
Yeah, 1 by 4 plus 4 square is equal to k square x square. But how will you go with the x then? What will be x here? X will be lying between 0 to 2. Yeah, this will also create a problem. X like k square x square when x is lying between 0 to 2. Similarly, you have to solve for the another part also, right?
Mm-hmm.
Two unknowns, one equation. Two unknowns, when there are two unknowns, you need two equation, right? So
Yes,
you have to take this equation as one and another one for another side, and like that you can solve.
like taking 2 base k x that equation, ma'am.
Yeah. Yes, whenever there are two unknowns, you
You
need
yes, ma'am.
two equation, right? And this x value is for this equation, your x value is lying between 0 to 2, right? From graph only we can have that. But I think better way will be this one only, negative infinity, to just break like that, whatever it is given, 0 to 2, right? 0 to
Ma'am,
2,
can you
2 to 4.
solve it once, please,
Yeah,
ma'am?
yes, I am solving on it. You got this method, but this will be very lengthy.
Yes, ma'am.
So we'll go with the integration part. This was I was giving you, if you have calculated height, then how to continue with that. Okay, you can have Pythagoras theorem and you can continue.
Yes, ma'am.
Your f of x is given as, it is kx, right? For range 0 to 2. For 2 to 4, what it is? K into minus x plus 4. When it is 2 to 4. 0 otherwise.
Ma'am, ma'am,
Yes.
in that case, like the above one, then I have to also find the value for 2 to 4, na? Like taking x value.
Yes. And if as f of x is PDF, we know that negative infinity to infinity, f of x dx is equal to 1. We know that f of x is 0 for rest of the part, so we will go for integral 0 to 2 kx dx plus 2 to 4 k into minus x plus 4 dx, which is equal to 1. That's it. We have to solve this only. Will you continue after that?
Ma'am, can you solve for that k minus x plus 4, that only?
Yeah, kx square by 2, 0 to 2, plus again k constant. You can have it like that. Okay, fine. You can do it like that. 2 to 4 minus x dx plus k, 4k again common, integral 2 to 4 1 dx. It's just addition, right? We can separate them, no problem.
Ma'am, how it
equal
is
to,
minus 2 and 1?
sorry, it is
Ma'am,
not
how?
minus 2, it's x. Sorry, yeah, it is x only. I have
Okay.
then minus kx plus 4k. You can have this like that. Sorry, 4k. Okay,
Yes, ma'am.
you got this point?
Yes, ma'am. Yes, ma'am.
Okay, fine. Then it will be 4 by 2, right? So 4 by 2 means twice k plus, sorry, let's say minus k x square by 2, 2 to 4, plus this will be 4k into 2, like 4 minus 2. 4 minus 2, which is equal to 1, right? Okay, like I had done just integration 1 dx is x only, right?
Yes, ma'am.
So 4 square minus 2 square, that means 16 minus 4. It's 12.
Yes, ma'am. Now I will solve it, ma'am.
Yeah.
Ma'am, just one more confusion, ma'am.
Yeah.
Ma'am, can you please explain ma'am integration of minus x? Like how it is?
Integration of minus x. Array, minus, just take minus outside. Integration of minus x dx is nothing but the minus integration x dx. I have taken the minus outside. No?
Okay, ma'am.
Yeah.
Got it, ma'am. Thank you so much, ma'am.
Yeah, sure. Anything else?
Yes, ma'am. Ma'am, and second question, ma'am, same assignment.
Okay. This one?
Yes, ma'am.
The random
Ma'am, here,
variable x as the PDF. Okay, yeah.
ma'am, here I have to consider A as to be like -4 and B to be 8.
Hmm.
But
They have
generally,
okay. It's given anything else about that? Okay, nothing. Yeah. No, you can't like that. It's not given that it's a, even though we can see it's a like what uniform distribution, you can have A as a -4 and B is a 8. But what if they say 1 by 12 x then?
yes, ma'am. But generally, the range is given to us na, for A and B. Like,
So this is range only, na?
yes, ma'am. So, what is A and B like for here?
A and B -4 and 8.
Okay.
Just check, you can cross check also. It's a 1 by 12, right? If you take A as a -4, B as a 8, then your PDF will be 1 upon B minus A. What is your
Hmm.
B minus A? It's again 12. So you can directly go for the variance of X formula for uniform distribution.
Yes, ma'am.
Got it?
Yes, ma'am. I got confused in that for A and B values, it is generally given as in the question like the range lies from A to B, like what questions I have solved in the activities.
Yes,
Uh,
yes.
Here I do not
Yes.
take from the range as A and B. Ma'am, did you get what I'm saying?
Yes, I got it. So in that kind of question, whenever you have doubt, you know how to calculate variance of X. Variance
Yes,
of
ma'am.
X, you know that, right? Expectation of X square minus expectation of X the whole square. Okay,
Yes,
if
ma'am.
you have doubt, then you can go like that. And do you know how to calculate expectation of X?
Yes, ma'am.
It is nothing but the integration X dx, X f of X dx. You
Hmm.
have f of X, so you can calculate E of X. Once you can calculate the expectation, you can easily go for the variance of X. That's
Okay.
why I checked what is 8 minus 4 is giving 12 or not, because it is uniform or not, that we have to confirm, right? If they have not mentioned, you should go like this only. It
By the
may be,
formula,
yeah,
by that integration one.
yeah. It may be possible that they will give, okay, f of X is like, okay, we can't do that because all these things are there. This PDF should be one, and there are a lot of things, so we can't just randomly make the question. But yeah, for this question, I will suggest you to go with the formula only, not that B minus A the whole square.
Integration one.
Yeah, integration one.
Yes, ma'am, because I also got confused. Like generally they give in separately na A and B
Yes,
values.
because
So we
X can
can't.
follow any distribution. It is uniform in this case, but it may not be sometimes.
Hmm.
If it is 1 by 11, then it's not, right? Because
Yes,
1
ma'am.
upon 8 plus 4 is not 11.
Hmm.
So I
So
will suggest you to go with the this manual method. And that is not also too long, right?
yes, ma'am.
Just two integration you will need. One with x into f of x, another x square f of x.
Yes, ma'am. So just by calculating fx, then fx will be that 1 by 12 and then integration.
Yes.
Fx will be, ma'am, 1 by 12, no? Then
1
into
by
x.
12 for the range -4 to 8.
Yes, ma'am. So I have to put that 1 by 12 x into dx.
Yeah.
and integrate from 8 minus 4 to 8.
Yes, yes.
Okay, ma'am. Thank you, ma'am. And ma'am, in that, in case of non-uniform distribution, ma'am, probability is like we found probability by that area under the graph, now.
Yes.
And for
It
the
depends. It's a discrete or continuous. Generally, non-uniform will be continuous only. It's just
yes,
like if it is a discrete random variable, go with the addition. If it is continuous random, go with the integration and go with the area under the curve.
mm, yes, ma'am. And ma'am,
Okay.
for like uniform also like area under the graph, and we can also go by the formulas now.
Yes, yes. We have discussed in like last to last lecture, last second.
Yes, ma'am. But I really got confused in these formulas, ma'am. That 9 to 12 have lot of formulas.
Better to have the conceptual clarity rather than the formulas. If you know how did you reach to that formula, that will be more beneficial. If you, in case you forget the formula also, if you remember what is the concept, then it will be very easy to get out from that confusion.
Yes, ma'am. Mm.
Okay. Any question?
Ma'am, last thing, ma'am.
Yes.
Ma'am, you explained that if lambda 1 is greater,
Yes.
then f of x2 will be greater.
Steepness of f of x1 will be greater. Steepness. That means rate of decreasing. Why I am saying rate of decreasing? Because in exponential, after that lambda, there is e to the power minus lambda x, which is a decreasing function. That means, and they have given that lambda is positive. That's why I am very sure that this function will definitely decrease. See, in exponential distribution, what is your f of x? It is lambda into e to the power minus lambda x. Once your lambda is positive, that means this function is decreasing, right?
Yes, ma'am.
Okay. So let's say your f of x1 is equal to lambda 1 e to the power minus lambda 1 x, and your f of x2 is lambda 2 into e to the power minus lambda 2 x. So your lambda 1 is greater than lambda 2. That means this function will decrease faster than this one. Okay.
Yeah.
So that's why this the steepness of this graph will be more than this one. And simultaneously, peak also will be higher in sometimes. Peak point for the f of x1 will be more than peak of f of x2.
Ma'am.
Okay.
Thank you, ma'am.
Okay, thank you. Anything else from anyone's side?
Excuse me.
Yes.
If you don't mind, can you please explain me uh, how where to use the PDF, and
PDF, CDF,
the
and
expectation variance and continuous expectations and the variance and continuous random variance. So here we have many formulas and
see. Okay.
in Week-12 we have many formulas like non-uniform and uniform.
Yes, yes, yes. I got your point.
And
See,
with, if you don't mind, can you please explain me a small example?
small.
Small examples. Otherwise, can you please clarify me?
Can you repeat your your voice is not clear. If there is something, please put in the chat. I will read that. Yes, hello. Okay, you want to explain me where to use PDF, CDF. Is that the question or anything else?
Yeah,
Okay, you
yes.
put in the text. Okay.
Yeah, that's
Yeah, see. When there will be a random variable, let's say X, it will follow some distribution. Okay. First, there will be a random variable in the picture. That random variable will follow some distribution. Okay.
yeah, ma'am.
We
Yes,
have
ma'am.
seen two type of distribution. One is continuous, one is discrete. That means random variable, whenever X is a random variable, just check whether it is a discrete random variable. Discrete random variable means what? It might be following some discrete distribution.
Yes, ma'am.
What
With a
does
limited
it mean
number
by
of
discrete then?
a countable
Discrete?
number of objects.
Yeah, its range will be countable. Range of X. Okay, you are studying math, so I can use the word range. Okay,
Okay, ma'am.
you know, right? What is countable? Uncountable. So whenever the
Yeah.
range will be countable, your distribution is discrete, otherwise it is continuous. Okay.
Yeah.
So first, your target will be to identify random variable. Second is whether it's a discrete or continuous. If it is discrete, or it is, there is only minute change between discrete and continuous, that it is a countable, like when we solve the expectation and all these things. In discrete random variable, all the operation will be with summation. In continuous, as it is a continuous, we can have a graph for that. And so area under the graph, area under the curve will come into picture, and we will go for the integration. Fine. Okay. So X is a, let's say X is any random variable. If X is any random variable, then it will follow some distribution. Okay.
Okay.
Once it comes distribution, then we are always interested with the probabilities of any event, right?
Yes, ma'am.
We are always interested about the probabilities. So
Yeah.
if it is a discrete distribution, let's say discrete distribution, then points are countable. So we can have probability of X is equal to K. Let's say K is any point. If it is a continuous, then obviously you can't go with each and every point because there are uncountable points, right? So we will go with the probability like X line between some A to B, right? A less than
Yes,
equal
ma'am.
to less than equal to B, like that, okay?
Okay.
Where A and B is some point, maybe your ranges are, okay? So whenever it is a discrete, you can go with a single point. You can find the probability for a single point. Then it is called as what?
Ma'am?
Then it is called as PMF. If we calculate for each and every point, probability of X is equal to Xi, then we say it as a PMF table. How we used to draw it? Let's say your X is taking some values.
Like up to N.
Okay. And we denote PMF as again F of X, right? Let's say your X is taking X1, X2, and X3. Then you will find, okay, F of X1. What is F of X1? What is F of X2? What is F of X3? Yeah, what is F of X here?
F of X is probability of the S1.
Right?
Yeah.
So that is PMF, probability mass function, right?
Function. Okay.
And for continuous, we can't have we can't calculate probability for each and every value, right? So we go for the range. How you calculate that? Integration F of X dx, right? Area under the curve.
Yes, ma'am.
A to B.
A to B.
Yeah. But what is F of X then? That's a problem. F of X is distribution function.
Yes,
Yeah.
ma'am. Distribution.
What we say it as a, what we say, F of X, P, D, F, right?
Yeah.
Got the difference between PMF and PDF?
Yes, ma'am. I got the difference.
Okay. Then there might be some question like, okay, now you have calculated for discrete, you have calculated the probability for each and every value. For this, you calculated for the range. Now
Okay.
it comes for cumulative kind of things.
Yes,
Okay.
ma'am.
In that
Yes, ma'am.
case, you want each and every probability before that point. Let's say
Okay.
there is a service center and you want to the service center working hours are from morning 9 to evening 7. Okay.
Okay. Okay.
And you are the owner and you are just going at 4 p.m. and you are asking, okay, what is the probability till 4 p.m. sorry. So you need each and every probability before 4 p.m. This
Okay.
is what
I'll sum
this
all
is
the probabilities.
cumulative. This kind of thing is called cumulative things, right?
Okay, ma'am.
So for that we have, right, CDF, cumulative distribution function.
Okay.
You know how to calculate CDF, right?
Yes, ma'am. Okay.
Okay. What is CDF? CDF is denoted as capital F of X, X is small x, which is nothing but the probability of your
Yes.
random variable is taking all the values till k,
Less than or equals to K. Okay.
right? For
Okay, ma'am.
both, whether it's a discrete or whether it's a continuous, the CDF is same. But where it makes a difference when it comes to calculating this value.
Calculating. Okay.
Here you will go with the summation. Here
Okay,
you
I
will
will
go.
go with
Here you will
addition.
go with the area under curve, right? That means nothing but the integration only,
Okay.
right? This is CDF. Then, okay. Then again, back to that question, service center. Now you want to calculate the average number of customers on a day, on a week, on a month, average, right? Whenever it comes to average, you have to go with the, let's say, in 2023, you have run your service center. Now you are moving to 2024. So you want to find, okay, what is the average number of customer will visit your customer service center at 1st January. You need some expected number of customers, like
Yeah.
you need some estimation.
Yeah.
That is what?
Expectation part.
Yeah. In both the case, again, it is same. It's x into f of x only for both the thing. But again, the same difference. Here it is countable point, so you will go with the summation. Here it's not countable, so you go with the integration. And we all know that integration is also summation only when you study Riemann integration.
Yes.
Right? Okay. Here comes the part of expectation.
Ma'am.
Yes.
In discrete variable, if you want to find how many members visit on January, we will go with sum of the average of previous year's January month, right? Ma'am?
Yeah. It's your choice. You can have various factors like, okay, day 1 of the year, then the factor might be first week of the month, might be like
my question is just if
what's
we
your
want to
service like last month, like December 23 month. It depends, like what's your target, right?
okay, ma'am, my question is if we want to find the what is the probability that
Probability that
customers come in the first day of week, then
that depends on factors. So like on
then should I
first
add all the customers that have arrived on first week
week of
first day
every
of
month,
the
of
then
every month,
divided by total customers
months,
that have
total months,
okay, ma'am. Okay, yes, ma'am. Total months.
right?
Okay.
You got the difference, right? Now
Yeah.
it comes to variance. Now, do you help me when variance will come?
Varies
Variance
between,
is,
if
yeah,
I get, if in 2022, if customers number is like 1,000,
okay.
and if in 2023 the customers number is different, like 500, and the remaining years if it varies, so we can find how the difference is going on.
Yeah, it's just a deviation from the mean value. That's it.
Yeah. Yes, ma'am.
Then, whenever the concern is about deviation, variance of x will come into the picture. Okay, any doubt? This was your doubt, right? You want me
ma'am.
to do this thing, right?
Yes, ma'am.
Okay.
Mhm.
Okay.
Thank you.
Yeah. Thank you.
Thank you so much.
Okay, then we are closing now. If there is any question, then please ask me. Otherwise, we will close.
Oh, ma'am.
Yes.
Oh, ma'am.
Okay. Fine. Thank you. Good night.
Thank you, ma'am. Good night, ma'am. Bye, ma'am.
Thanks, ma'am. Good night.
Yeah. Good night.
Thank you, ma'am.
Good night.